Welcome to the setup and instructional movie for the sensors portion of the Iron Eagle demonstration. There are a few, well, there's one setup operation I need you to perform. On the DVD, or if you've copied the DVD contents to your hard drive, I need you to go to the demo setup folder. Under the demo setup folder, you will find files to copy. You will see there's a program folder, and then there is a custom folder. This custom folder, you will find a custom sensor folder. And if you will notice where you have Solid Edge installed, there's a custom folder, and then there is a custom sensor folder. And all I need you to do is simply drag and drop this DLL onto the existing DLL that you have. What this does is, well, you'll see in the demonstration what it does. And then what I need you to do is register this custom sensor. So you just double click on the register, hit OK, hit yes, hit OK. There is a 64-bit registration as well. Okay. So now you will see this portion of the demonstration will take place right after the animation demonstration that Mark showed you. So you don't need to get out of the assembly. You don't need to go back to the top level. You can work right inside of this assembly. We want to make this easy for you. So you can go directly into the sensors configuration. And what we want to do is we want to show people how sensors work inside of Solid Edge, and you can talk about how inside of assembly we have three different types of sensors. We have minimum distance, we have variables, and we have custom sensor, and just point out to them that the variable sensor can be used for any variable, even ones that they create on their own. Can also be monitored that. So what we want to do is we want to show them very simply what sensors do and perform, and how easy they are to set up. So basically we want to do a clearance sensor inside of the assembly, and you can show them the different operators that can be performed. In this particular one, we just want to say, tell me whenever this value is out of this particular range. And you can see that within inside of the 170, 180 range is where we want to maintain. We don't want to get out of that particular range, and you can see that everything is fine. Next, what we want to perform is we want to perform in place activate. Into what we're going to be doing here is we're going to be showing off a couple of things. One is if you just switch over to the flat pattern tab before you go any further, and what we want to do is we want to make people aware of the information that is provided for a flat pattern. And you'll see inside of this sheet metal file we have the cut size is always provided, but Solid Edge users have the ability to input what the maximum values are. Now you can choose to show this or not. It's totally up to you if you want to do this, but under the Solid Edge options there is a flat pattern, and you'll see that there is a default cut size. So in other words, this is the size of sheet that I want to maintain for this particular file, and so the user can input that, and at any point in time Solid Edge will let you know if you're out of your range. Well, what I've gone and done is I've also went and I've set up a particular sensor, or two sensors. One is monitoring the height of the part and also the width of the part, and so we can set those up as sensors as well. But the next thing that we want to do is we want to take a look at a custom sensor, and this is the one where we want to look at the mass. We want to always monitor what the mass of this is, so we can say either the mass or the weight of this part, and we see what its current value is, and no greater than, let's say, 14, and which range is, we'll say 10 to 20. And we can see that it's instantly out of date. It's a little too heavy for what we want. So we can go through and simply show some modifications. Now, before we go perform the modification, I want to show one other type of sensor. And you want to be able to show off maybe a sheet metal sensor to show that we can look at an entire part or a particular face. And let's say on a particular face where holes are getting too close to an edge. So I want to look at holes or cutouts. Let's say on this particular one, let's just say cutouts to exterior edges. And you can see that there's already predefined ones as well for the users, but we just want to put that in here, and we'll just say holes to edge, and we'll just say value, tell me whenever it's within 3 millimeters. Okay, and right now we can see that it is a go no go gauge, and that we are good to go for that particular one. And then we can also show that there's a surface area, and we want to provide, let's say, the negative area for this. And you can talk about this as being airflow, and how somebody can monitor this type of operation. And we'll just say airflow for this particular one. And again, we need to have tell me when it's less than a particular value, and we'll say when it's less than, I don't know, let's say 40,000 millimeters squared, and we'll just say 30,000 and 50,000 millimeters squared. And so now we can see that both of these, we'll just expand this out, we can see that both our weight and our airflow are both out of date. And so what we're simply going to do is grab this particular slot, and we're going to increase its size. And as we increase the size, you'll see that the airflow one is instantly updating. Okay, the weight is not instantly updating because we haven't finished the form yet, because weight is always calculated after we perform an edit. But the airflow one instantly shows what that is, and we can see that we're validating that one. And once we perform, we can see that we're quite not there just yet with our weight. So again, you can perform that edit just one more time, single that out to make sure that we get our weight, and we can see that our weight is now within size, and our airflow is also inside as well. And so it's just something to show off sensors very quickly, very easily, and it shows very nicely in this particular case. And so hopefully we'll be able to convey to our users exactly how sensors and how they can benefit them through the design process. At this point in time, you simply just close and return, go back up to the top level to move on to the next demonstration, which will be the Rapid Blue demonstration performed by Doug. This concludes this demonstration for sensors.